Okay, great. Let's start. Good afternoon, everyone, and welcome to our webinar. So the goal of today is knowledge sharing, and the topic of today is looking at the threat actor behind the Sunburst Solarwinds attack. So I would like to introduce myself. First, I'd like to start with thanking both speakers of today, Ron and Bart. Thank you very much for joining us today, but also all of you. Quickly introduce myself. My name is Stan van Hof, and I'm a business development manager at Exclusive Networks. We are the added value-added distributor for cybersecurity. I'm responsible for FireEye, and it's with a great focus on managed security validation. So today is about knowledge sharing, and more specific, the Sunburst Solarwinds attack. But I would be a bad business development manager if I did not take this opportunity to quickly pitch an idea or a great solution of FireEye Mandiant. It will just take 2 minutes, and after that, Ron, Bushar, and Bart Vanautgaerden will take over. So managed security validation is an automated tool that you can use to continuously validate and monitor the effectiveness of your security stack against advanced threats and known threat actors. What we can also do is provide a more specific use case. So we can leverage the same tool to test your environment against a specific use case. For example, the ransomware test with Maze. So what we do is you install an endpoint agent on your corporate network, and FireEye Mandiant will do the testing and provide a comprehensive report to see how well your network and endpoint security was able to block the attack. If you are interested, you can always contact me. My details are below, or please visit our website, or just Google Exclusive Networks and FireEye, where we have a lot more information about the different products of FireEye and also presentations. So thank you very much. The speakers of today are Ron Bushar. He's a Senior Vice President and CTO for Government Solutions, and Bart Vanautgaerden. He's a Senior Incident Response Consultant. Both are cybersecurity experts with more than 20 years of experience and the perfect speakers for today. So I'm going to change the presenter to Ron. And
perfect, thank you. And thanks everyone for joining this afternoon. So want to dive right into a little bit of a technical analysis of what we observed both in our own intrusion as well as the larger Solarwinds supply chain attack that we uncovered as a result of that investigation. The group we tagged for this is an unknown group currently, so we call them UNC groups. This particular campaign and group we tagged as 2452, so we'll refer to that group throughout the briefing. You get to see our pre-COVID looks here. Obviously, Bart and I are a little bit more casual these days, working from our homes, but hopefully someday we'll return to suit and ties or suit and no ties. I won't bore you with the details, but yeah, we spent a lot of time, both Bart and I, in both government service as well as commercial incident response and cyber operations support throughout careers. So on to the attack. So on December 8th, as last year, as most of you are probably aware, we announced publicly that we had a breach in our corporate environment. And as a result of that breach, we had learned that a good portion of our internal RedTeam tools were taken by the adversary. We made this announcement for a couple of reasons. Number one, we felt it was the right thing to do for the community in general, just to make, because of the sophistication and of course, prior to the Solarwinds knowledge, even before that, we understood that this was a very sophisticated, capable actor who very well may have been targeting other, other organizations with similar profiles to us, or potentially government organizations. That was based on some of the analysis we had already done as part of our investigation. But the secondary reasoning, or really the primary. I'm sorry, was that Bart?
But we haven't got the visuals on the slides. Maybe check your settings just for a minute.
Interesting.
Apologies.
Sorry about that. I thought I was sharing. Show? Is that working?
No.
Can you see that?
See your mouse, but we don't see the screen.
Okay, let me just try. Sorry about that. Always fun with technical difficulties. Let me just try showing my entire screen. Does that work?
Yeah.
All right. Well, as I was saying, our beautiful portraits. Fast forward. You didn't really miss much from a content perspective, so don't worry. So we, the primary reason we wanted to publicly disclose what was happening was the loss of our RedTeam tools. So these were a collection of internal tools that we had developed to test and validate our customers' security and to provide training to customers in order to, accurately emulate adversary activity by using tools very similar to what our adversaries are using against us. Unfortunately, when you lose control of tools like that, even though they didn't contain any 0 days or any sort of non-public exploits, they still represent, obviously a risk to the general public and to other organizations if we don't properly provide countermeasures and detections for them. So in our announcement, as part of our release, we work closely with both our government partners and our commercial partners and our customers to provide over 500 countermeasures to the tools that we had in our repository that we know were taken. And this repository of detections and countermeasures are still available on our website. We are to maintaining those throughout 2021. We're constantly updating them, although the pace has slowed down significantly over the past few weeks and months. We've gotten to a pretty good level, we think, of efficacy at this point. These are deployed in all of our customer environments and all of our technologies, so you have them built in if you're using our tools. Microsoft and other security vendors have also implemented similar detections in their security stack. So at this stage, based on that visibility worldwide, we have no evidence that this actor group has either tried to use these tools in a real world operation or has made them available to other adversary groups to use. We've seen no unauthorized use of these tools in any victim environments. We know they work because we actually caught our own red team using these detections in a few engagements over the past few months, as part of authorized activity in our client environments. So we had learned a lot at this stage in the investigation about the actors' capabilities, their targeting, what they were interested in, obviously, but we could not figure out, or we had not yet figured out, how they got initial access. So that patient zero, that first mechanism in the environment, is obviously critical in any investigation, because you really can't have a high confidence that you fully remediated the breach and ensure that the actor can't get back into the environment unless you understand how they first got it. If that mechanism is not well understood, you run a risk that they are going to continue to come back into the environment and continue to compromise your data, your systems, etc. So we continued our investigation even after the public announcement, and where that led was into our Solarwinds environment for a couple of reasons. We had a detection from our own endpoint agent running on those servers. Part of our agent includes a machine learning algorithm. We call it Malwareguard, and that piece of technology had caught a partial execution of a variation of Cobalt Strike Beacon C2 tool. It had not fully executed. It was memory only resident, so we weren't able to fully recover the file or the executable, but we did know that somehow that tool had gotten onto that system and was at least attempted to be run. But the trick to that whole kill chain was we didn't know how it got there, right? We had no evidence of lateral movement in or out of in our SolarWinds environment. We had no evidence of any sort of internet traffic to or from those systems that look suspicious, and we had no evidence at that point that the adversary had compromised any credentials on that system. So we were puzzled, or really stumped as to how they had gotten access to those systems. And this was, we spent a lot of time looking through log analysis, looking through adjacent systems, other network telemetry. We really couldn't find that smoking gun or that piece of evidence that really told us how this had happened. So we took a fairly unprecedented step at that stage for a couple of reasons. One, again, knowing the sophistication of the actor we were up against, but also just our internal need to know, right? We had a lot of our own incident response experts running this investigation, and there was just a professional desire to figure this out. And so we spent about 700 to 800 man hours actually deciding. We decided that we were going to look at every single file, every single executable on that server, and just assume something else was on there, some other bad mechanism was on there that we had not yet identified. So when we did that, we finally came across this element that pointed in the direction of a supply chain backdoor. What ended up occurring, we ended up discovering, which we'll get into more detail in a minute, is a small sliver of code inserted inside of a DLL, which was part of a larger update package hotfix that was provided by Solarwinds. So we found this evidence of a malicious backdoor, inside of this, what appeared to be a legitimate Solarwinds executable. We had to answer two questions really quickly. Number one, was that somehow placed there in our environment only by the adversary, or did it in fact come from Solarwinds? That was fairly easy to figure out. We were able to essentially download another hotfix update from Solarwinds and validate the exact same vulnerability, or not vulnerability, but implant. And number two, we had to start writing detections for it and just figuring out, which we assumed based on that first answer, that other victims were potentially out there, that were leveraged using this mechanism. And in fact, what we had learned ahead of our public announcement on December 14th, we pre-notified Solarwinds. We worked with law enforcement entities to notify them about this issue. And again, we worked with a lot of our customers and partners to start looking, across their environments to see if this was in fact impacting any of our customers. And we quickly learned it was impacting hundreds of our customers potentially. So we, from our own visibility, knew of hundreds. Solarwinds, once they took a look at, the distribution of what was potentially put out there, they came out and publicly said that about half of their total Orion customers potentially had a trojanized version. So that puts the total victim universe of about 18,000. Now, what we know since then is that, in fact, this actor was only targeting a second stage mechanism or of interest beyond this first stage access, a very small number. We have that number less than 50. I think Microsoft is saying around or potentially slightly less than 100. So you can see that decrease in aperture of victimology as this campaign unfolded. So what do we know based on our initial analysis about this group? Well, obviously highly skilled enough to understand how to get inside of a software supply chain of a global software vendor and compromise a signed, software deployment mechanism, and create very sophisticated command and control and infrastructure to control all of that distribution, and then very, very stealthily access victim environments in ways that, up until our investigation, had really resulted in no one detecting what was actually happening. So they're high priority on stealth, high operational security, a very sophisticated understanding of network defense and cyber operations defense mechanisms, and specifically how security operations staff would normally investigate, discover, and remediate a typical breach in an environment. We also understand this to be a very long-running and well-resourced campaign, just from the artifacts we know about from both the C2 infrastructure and when that was stood up, which was in late 2019. We have evidence from Solarwinds that initial testing of this implant was occurring in late 2019 as well. They had a version in a hotfix that had the DLL code hook in it, but it didn't actually do anything. So they were testing the deployment and presumably making sure that it was undetectable as part of this mechanism. And then we know that the first real live deployments went out in March of 2020. So we believe that this campaign was obviously, stood up over a long period of time and then was intended to run for multiple years until they were detected. When you look at victimology, who do they really target beyond that initial deployment? So if you look at the left-hand pie chart, that's what you would expect to see from a typical who uses Solarwinds generally globally. And this is every region around the world. This isn't just the United States. So when you look at this, you kind of see every typical sector you would expect in an enterprise type of customer set, right? That would use Solarwinds software. But when you then dive into who did they actually come back into and provides what we call second stage, access mechanisms, further compromise accounts, and actually start to steal data, there's really only three categories at that point. It's government adjacent agencies, think tanks, etc. It's technology organizations like ourselves, and it's education, higher education research organizations. And the vast majority are in the United States. So that kind of gives you some information about, or at least it points you in a direction in terms of attribution. Who would be interested in these particular sectors with the wherewithal to build an implant like this and put it into widespread global distribution and then take advantage of it, but only targeting very specific victim sets. And we'll talk a little bit more about the attribution in a little bit. Another clue we had was the information they were targeting not only in our environment, but in other victim environments that we're aware of. So they were certainly targeting internal documents and email that might have value from an espionage perspective. They were targeting intellectual property, mostly focused, from what we can tell, on potentially other supply chain opportunity space. So code, source code, things of that nature that may have had interest in further compromising. And interestingly, the third area which we see commonality is a focus, especially at the early stages of their attack after the Solarwinds component, of focusing on internal security documents and security team members. So a very narrow focus on personnel, staff, emails, and documentation about how that organization provides IT security, cybersecurity, operations support to protect the environment. So again, a very sophisticated understanding of close attention paid to exactly how they may get caught in the environment and taking steps to avoid that in every case. But importantly, again, in all the victim space that we're aware of, this actor certainly had opportunities to steal what we would consider more financially valuable information, PII, financial data, executive emails, things that you could potentially ransom for payment. None of that was that we could see had been really targeted by this actor group. And similarly, we have seen no indication of destructive or disruptive goals, no tooling or deletion of data, manipulation of data beyond some small tradecraft techniques, which I'll talk about in a minute. So how did they accomplish all this, right? What were their process to do this? Well, there's really 5 main mechanisms that are fairly unique, or at least somewhat novel to this actor group, or something we have not seen widely in all of our analysis and investigations around the world. Number one, or a few at the top, they really paid quite a bit of attention into maintaining stealthy access into the environment beyond the Solarwinds implant. How did they do that? Well, they set up their C2, their command and control, very, very carefully to very accurately and as closely as possible emulate their victim environment. That includes the way they built those systems that were accessing the environment, either through VPN or other remote access mechanisms. It includes where they put those server systems. So in every case we know about, they place these C2 nodes in the same geography, same country usually, and located very, very geographically close in space to the victim environment. That was, we believe, an attempt to, again, avoid typical behavioral detections, impossible travel analysis, things of that nature, and to make the traffic look fairly benign. A lot of security operations, centers, especially more sophisticated ones these days, will do a lot more network analysis to pick out, unusual traffic that would, transverse, countries or regions or geographies that might look suspicious. So by putting these IPs within the same geography, country that they're attacking, it kind of hides some of that in plain sight. Very little use of additional malware. So they didn't have a big malware footprint, which again really aids in being stealthy in the environment. So beyond what we call Sunburst, which is the Solarwinds implant, we detected in our environment this variation of, as I say, Cobalt Strike Beacon, which we call Teardrop. There's a few other mechanisms you may have read about, a few other tools that they have used for additional command and control and access. But in every case, the tools they're using beyond the really customized Solarwinds implant are essentially commodity attack tools that a number of both legitimate red teams as well as adversaries use on a regular basis. It doesn't point you in any specific direction. They're not using anything highly customized there. So the attribution angle on any additional malware is really non-existent. Beyond the initial access, their lateral movement mechanisms are highly sophisticated. And Bart will talk a little bit about how you can detect both this specific attack and others that might emulate it in the future. But what we found is that they had a very, very mature understanding of exactly how Active Directory identity architecture works, how to attack it, and how to compromise it very quickly, and then begin living off the land in the environment by using golden SAML attack mechanisms to essentially operate as authorized users in the environment. The one stealthy mechanism we did see them do, it's not really destructive, but is really kind of file replacement and temporary task modification elements, which basically means in any system where they were trying to elevate privileges or they had to manipulate something on the server beyond what was available to a normal user on that system, they were very careful to only put trojanized variants of either tasks or files temporarily on the system, execute them, then remove them and replace them back with what was there to begin with. So leaving a very small trail of forensic evidence behind them in any case where they had to really manipulate systems in an unusual way. So a few details about the implant itself, the Solarwinds implant. Of course, we expect to learn more details about how this actually was compromised within Solarwinds environment, but that investigation is ongoing. But you can see just, again, the complexity here. They, within this single DLL, there's over 400 classes, 3,000 methods, 45,000 lines of code. Actual implant mechanism that executed the namespace here that actually kicked off the back door was only about 20 lines of code. So they hit a very small needle inside of another stack of needles inside of a very, very large haystack, as a really tortured metaphor. And when you think about it, even inside of this package from Solarwinds, that one file represents only one out of about 120 total files, tens of gigs of data that was provided by Solarwinds. So they're very, very stealthy in the way they were able to insert this code. The other interesting fact here is they paid a lot of attention, and they clearly had a good understanding of exactly how this Orion software worked. They took very careful steps to name all of their processes, all of their network protocol components to look exactly like what you would expect to see in a standard Solarwinds environment or a standard Solarwinds server. They also were very careful about how they distributed this implant. So the first evidence we have of a fully functional capability was March 26th of 2020. We see other variants that popped up in other hotfix distributions between April and May of 2020, but then they took it away. So there's future updates in June, July, August timeframe of 2020 that did not have the implant. So our supposition is they put this into the supply chain stream. It got to those 18,000 plus victims roughly. And out of that, they were able to determine, oh, we got where we wanted to go, right? We got into the victim space that we were most interested in. Let's take it out so we don't make it obvious and hopefully people will not discover this and only go after then subsequently attacking those victims in that second stage mechanism that are of interest to us. Very, very sophisticated initial C2 capabilities. I don't want to spend a lot of time on this, but the way they were able to, we think, really manage such a large environment, when you think about it from an attacker perspective, you've got thousands of potential victims beaconing in each day, right? When you put this into an attack like this, how do you track where they land? How do you track who you have access to? They really did some sophisticated encryption and DGA pieces here to really, on the initial call out, on the initial DNS callback, bucketize where they landed and provide some information about where they were in the environment. So they encoded Active Directory domain and host information inside of that host name, that what appears to be a random name there that starts with UT. And they actually were, the code was fairly clever in which of these subdomains of the ABS VM cloud domain were actually utilized, right? So that gave them geography, and it also gave them some indication of the domain and obviously the victim environment that they had landed in. From there, again, they were quickly able in most cases to pivot away from Sunburst, and they're very careful not to go back to it. In our case and in other cases, we see no evidence that once they were able to maintain or establish other C2 mechanisms, they never went back to the Sunburst component. So again, we think an attempt to stay far away from any sort of attribution or have any hint that that was happening in their environment. I just realized that. Are you guys, Bart? Are you guys seeing my my dashboard as part of your screen? I apologize.
Yeah, no worries.
Not doing my not doing my tech quite well today. Sorry about that. So we also, again, their second stage was either customized variants of standard tools, Beacon, Mimikatz, etc. But they were only using that second stage temporarily to gain access to the credentials that they really cared about, which in almost every case were these mechanisms around SAML golden gate attack, usually targeting an ADFS server environment. Once they had that stage 2 access, now they could emulate any legitimate user in the environment that they needed, and they could then pivot to both Azure cloud environments as well as on-prem Active Directory applications or Active Directory or applications that were Active Directory enabled for authentication. In our case, again, that's how they were able to pivot into our internal Git repository environment and take our RedTeam tools. And in other environments, again, we see focus on things like email, SharePoint directories, things of that nature. So in reality, there wasn't a lot of persistence and exfil from a traditional attack perspective with this attacker. They were essentially acting and behaving as legitimate users. Very sophisticated, again, understanding of detection mechanisms that are typically used by network defenders. So for instance, if there was a multi-factor component, they would either look for ways to steal the secret keys associated with that, or self-register their own duo tokens or other types of two-factor tokens as authorized users and use those mechanisms to come into the environment. Similarly, they would they would be careful about which accounts they were using. So they would use one account for remote access, and then once they had access to the environment, they would actually enable other accounts to go to the servers and systems they were interested in. In many cases, in order, we think, again, to avoid detection, they were actually not even using individual user accounts. They were using federated service accounts within Azure or within on-prem applications. So again, another layer that a lot of net defenders don't tend to pay as much attention to are those kind of service level accounts or automated application accounts, but they had the rights that they needed to access the data they were interested in, things like email, for instance. No real exfiltration from a traditional sense. We don't see them staging tar files or large bulk data. They typically, again, will use the exact same mechanisms as a user would. So they'll use, again, they'll use Git commands with an authorized user in a Git repo. They used API calls to mailboxes to selectively exfil only specific messages that met search criteria or selectors. So they weren't bulk downloading inboxes. Again, trying to avoid any sort of obvious large-scale data collection. Unlike a lot of groups we see that get a little bit sloppy with tradecraft, this group appears to be very, very disciplined. So we never saw them touching individual workstations, for instance. They didn't go to folders or files on systems and just download randomly. Very focused on enterprise systems, data repositories, and only in those specific focus areas of the collection, what appears to be the collection mandate that they were working under. So on attribution, very, very challenging group from attribution. Again, they made almost no mistakes when it comes to operational security, to anything that was done either from tooling, behavior, anything in their C2 environments that would point to an obvious, attribution to a specific group. What we do know is they didn't, again, no appearance of any sort of monetary focus here, nothing that was taken beyond extortion potentially, which you haven't seen any evidence of, or sale in the black market, such as our RedTeam tools, which again, we also don't have any evidence that that's occurring, have no monetary value whatsoever, but they definitely have significant value to governments or government agencies. and no disruptive activity. So certainly not a traditional ransomware style of attack mechanism here. Again, very, very high emphasis on that stealthy aspect, that persistence. My supposition, our team supposition on this entire campaign was this was designed to operate undetected for many, many years, right, as a persistent access and collection mechanism. And again, beyond the initial backdoor, the Sunburst backdoor access mechanism, once they had established this SAML attack mechanism in the environment, they're very thoughtful about how they created additional backups to that access. So we learned a lot of lessons, which we put into a white paper. I highly recommend you take a look at in hardening and defensibility of both Azure and ADFS environments. But one thing we learned early on is that they would create trusted domains, new domains attached to the parent forest or parent domain of the organization. And what that allowed them to do is if you thought there was a problem and you rotated passwords and certificates like you normally do, if you thought there was a compromise of credentials, they had a mechanism to then revert back to that other trusted domain and continue access and then reattack and recompromise those same token signing certificates again. And so unless you do, and there's a lot of components here that get into the weeds of Active Directory, but there's a built-in cache mechanism such that they also had, access for a period of time, even if that domain mechanism didn't work. So the only thing that would work in this case, and it, was what eventually what allowed us to enable us to kick the attacker out of the environment fully, was actually rotating those certs and passwords twice within a very small period of time. Something you normally would not think about in a typical incident response scenario. So again, that really novel, some of the novel techniques they were using, which we had to learn as we went on this one, really pointed to a very, very mature understanding of persistence and stealthy access into environments. And again, the last point here is when you think about what was done, right, from a global supply chain perspective, this group was either enabled, authorized, or operating under the the mechanism of, or the mandate that said you can compromise, you can have collateral damage that includes tens of thousands of associated victims that you can put this backdoor into, as long as you get to your end target. So I read that as a fairly brazen authorization, if you will, or at least a fairly brazen technique in order to get the access that they were really looking for. We can't, at this stage, based on the information we have available to us, really firmly attribute to any particular group. That's why it's still an ungroup here. And we can't certainly name specific actors, specific agencies, or countries. The US government and the intelligence community has come out and said it's a likely Russian origin attack vector. It's plausible to us based on, the targeting of the data, the victimology, the techniques, the sophistication. They do point in that direction, but again, very, very few mistakes made here from an operational security perspective. Nothing that is that smoking gun that gives us that easy, yes, definitely this group. And of course, we're continuing to collect data, track this group, work with other partners in the community. And I do believe at some point we'll have more evidence that will more firmly link to a particular group and ultimately to what we assess to be the ultimate end goals of this campaign. But we're not there yet. So Bart, I want to hand it over to you at this point to talk a little bit about how do you hunt for an actor, well, this actor in particular, but maybe more generally, how do you look for these sorts of techniques if they're going to be repurposed, which they most likely will be in future attacks as well?
Yes, thanks, Ron. Thanks also for that insight into the incident itself. Yeah, just a few words about Mandiant Consulting, of which I'm part of. My day-to-day life is an incident responder, so I hunt in customer networks for adversaries. Either companies and organizations have been breached, and so they come to us for assistance. So then we sweep the networks and we try to find out where the bad guys are hiding into the network itself, whether they've deployed malware or they're moving laterally into the environment. Or they come to us with a question of, hey, am I compromised? Meaning they're not sure yet if there's actually an adversary into their network, and they ask us for advice and to provide a statement whether the network is clean and not, and to which state. We also do many other things. We help organizations secure their cyber defense. We also do red teaming exercises where we emulate the same things as we learn during these campaigns. We emulate them for our customers. We also do tabletop exercises where we talk to your management, and we try to do a playbook, try to see how you would deal with such an incident. But enough about manual consulting itself. Let's move on to how we would approach these incidents. And in fact, actually, since we've came out with this incident that affected us as an organization, we've also helped many other organizations dealing with exactly the same thing. As Ron has detailed, there is potentially 18,000 organizations that had Solarwinds installed, that had the malicious update pushed them, but not all of them, of course, had the malicious second stage. So the first question to you as an organization is, are you currently at this moment using Solarwinds? And of course, if you are, then definitely you should have already gone to the next step, is trying to understand into your environment, well, how do you use Solarwinds, right? Where is it situated within your network? Does it have access to the internet, for example? Has it been updated? And if it was updated, did it have the trojanized version of that specific DLL? And so that is really important. If you haven't got those questions answered yet, I think it's definitely time to start investigating, talk to your network management team. Third point is also, as Ron explained, they're moving laterally within the environment, meaning initially they'll use a Solarwinds authorized installation within your network, but using a trojanized version, and then from there on they have access to it within your environment and then move laterally. And what do we mean by moving laterally? Is they're using what they call living of the land binaries. They're using PowerShell scripting. They're using other persistence methods, which I will talk about, to get access within your environment, and then eventually may jump also to your cloud environment. That brings me to the last point. It is not a threat actor that stays within your on-premise environment. We've seen in cases moving to the cloud environment with the attacks, with the mechanisms that Ron has talked about. Just one point on visibility. What do we mean with visibility? Is making your environment investigation ready. Right? Investigation ready at multiple fronts. On one hand, definitely your endpoints. In this case, we haven't seen the threat actor moving towards workstations, so predominantly on the server side. Visibility at your network layer, meaning what data gets out of your network from your host within your network and towards the internet. And lastly, also ingress towards your network. So your VPN, whether that's protected with multi-factor authentication or not. And I will talk about this point. Next slide, Ron. So of course, let's start with the easy, quick wins. As I've mentioned before, if you're using Solarwinds, definitely this is something that you should verify now. We have very early on in December made public the Sunburst, which is our name of the trojanized version of the Solarwinds DLL that was subverted to contain this malicious code. We've made available the threat intelligence related to this. Other companies have also done the same. So if not already detected, verify whether at one point in time, because this may have been reverted in the meantime, either deliberately or not, if you were running at one point in time this specific version of the DLL. I've actually over here on the right upper corner, trust but verify. I've asked organizations whether they've used Solarwinds, and the answer is often no. But actually, when we do sweep the environment, there is sometimes installation of a Solarwinds within the network. So it's definitely something to verify. Next is checking whether any of the malicious payloads also have been existing within your environment at the moment, or again, at one point in time. Ron mentioned this teardrop, which is basically a repurposed beacon, part of the Cobalt Strike red teaming tools, or other tooling like Mimikatz. So these are the elements that we can use at the endpoint on the server side. On the network side, we have another mechanism that we can use. Of course, looking at your network data, your DNS logs, your web proxy logs, anything that went out over the past couple of months to this domain or associated other domains we have publicly made available for our partners, definitely has something to look into, and then try to identify what was the origin of that system, and then start your investigation from this point on. Of course, endpoint detection and response technology, ADR, can be used to sweep your environment, and that's also what we do at Mandiant. Typically, we get into an environment, deploy our FireEye HX technology, and then we sweep your estate to verify these traces. But you can also use different tooling. Next slide, please. But of course, the low-hanging fruit, the host-based indicators, that will be easy. We have seen this threat actor moving within the network and using very little malware. And of course, malware provides an attacker with a tool, with a toolkit. And so they can use keyloggers, or they can use different mechanisms, but it also leaves traces, and traces that people like myself are on the lookout for. So this threat actor was very carefully to not use too much malware, and then to move within the environment using, for example, PowerShell or WMI. We've seen traces also of the attacker clearing Windows event logs, creating scheduled tasks, and as Ron mentioned, sometimes changing the binary underneath it, so that at one point in time, it was pointing at a legitimate binary, but then pointed to a different one and executed, of course, for malicious purposes. And then secondly, once the attacker got comfortable in environment, they may move to getting into your network without using a Solarwinds installation, but using VPN. The same VPN you're keeping up and running now in the COVID days to keep your teleworkers connected to the network. As Ron mentioned, they were also careful of picking the exit points or the entry points to your VPN to pick and choose the ones that are close to your VPN. Meaning, if you would be a Belgian-based organization, they would appear to come into your networks from a Belgian-based IP address. But in different scenarios with different threat actors, they may get into your environment from unexpected locations. And we also spot, like sometimes, geo-invisibilities. So when we see an authentication getting an authorized user getting into your VPN, and at the same end, 30 minutes later, the same connection is getting into your network from Mongolia, that would be strange, right? Because you cannot impossibly travel at that speed between Belgium and Mongolia. What we have seen for this particular threat actor is that they were careful to choose IP addresses in the same region, but then originating from data centers, right? And how many times would you see a regular connecting in to your network from an Azure rented computer or from another hosting provider into your environment?
Sorry, I'm on mute.
Yeah, no worries. Could you show up the slide, please? Yeah.
Working from home.
Ron, can you show again the slides? Yeah, so again, the VPN logs provide a wealth of information for this. And as other vendors have also mentioned, sometimes also misusing multi-factor authentication. So that, of course, is a very strong deterrent, but it's not a safeguard for advanced threat actors like this one. Next slide, please. And then lastly, of course, pivoting to the cloud environment. Many organizations are already using the Microsoft cloud services like Azure and MS365. We've seen this threat actor moving within that environment and then misusing several mechanisms within the cloud environment, such as use of federation or misuse of federation, those trusted domains Ron talked about, misuse of service principal names, or adding privileged API keys so that they can actually pull back mailboxes or in specific emails that they're interested in. We've released a PowerShell tool that you can easily run in a read-only mode against your Azure environment. What you need to do is a couple of steps, which we explain on our GitHub page. It's called the Mandiant's Azure AD Investigator. And we have also a 30-page document that explains what you should be on the lookout for. One point of attention on this white paper, and if you would decide to execute this or ask your staff to execute this against your cloud environment, is not everything that comes out of it is definitely a sign of compromise, but it's definitely something that you would need to investigate, right? If you may have in your environment a privileged API key to do a specific task within your environment, but that is something to double check where this is originating from. And again, we've designed this tool to be on the lookout for this threat actor traces, but other threat actors can use the same mechanisms. All right, so this brings me to the end of our presentation. There's also a reference to where you can find more information about the indicators we've shared. And also you can reach out to our partner, Exclusive Networks, for any other questions. With this, I wanted to open the floor for any questions you may have for either myself, Ron, or for Exclusive. If you have any questions, you can throw them into the chat itself.
Okay, I've got a first question. It's from someone who asked what the impact to Europe is, because you focused on the US. So what's the impact on Europe?
Yeah, from our visibility, it is mostly, the second stage is mostly US focused victimology. Obviously, us as a US company, you know, there's been a few other public announcements of other software vendors like Palo Alto as potentially targeted by this group, and then of course US agencies that have been publicly reported on. We know that, again, the distribution of the first stage component certainly had a lot of organizations in Europe, across Europe, but that to us appears to be a randomized distribution based on that essentially uncontrolled supply chain insertion. Bart, I don't know if we have any specific evidence of any European entities at this stage being targeted by second stage activity. I think I heard Microsoft say that there were at least a few that they were aware of, but I don't have any specifics.
Yeah, indeed. So we actually are working with organizations that have certainly had a compromised, or sorry, a trojanized Solarwinds installation. But of course, we work with them to try to uncover whether this only went to the step of the trojanized version, but not the second stage in itself. So that's the visibility that we have. So yes, definitely Europe has been on the radar, but not so much. It has been heavily skewed towards the US for the moment for the second stage.
Okay, thank you very much. Another question: if you're not using SolarWinds, are you good? I mean, do you have to worry about the threat actor?
Yeah, it's a little bit of yes and no. The primary mechanism for most of the victims we're aware of, you know, utilize the SolarWinds implant. However, there's been reporting through several public reports, as well as we're aware of other mechanisms that we think the same actor group or adjacent actors have used. So you may have read about the Mimecast compromise of certificates. That's an example that at this stage sort of we think maybe is linked, to this campaign, but we can't say for certain. There's other evidence that this actor group was using other mechanisms if they needed to gain access to environments. So I would certainly pay attention primarily to the Solarwinds component, but I would also utilize the components that Bart talked about. And I would certainly also look at our white paper in terms of audit and hardening of your Active Directory environments, because in every case, regardless of the initial access vector, this group is going after those SAML tokens in that second stage golden ticket attack. So I would not necessarily say you're 100% safe without evidence of that SolarWinds component. It certainly puts you in a much better position overall, but we have seen some targeted access into other environments that don't use SolarWinds. And of course, without stating the obvious, however they got into SolarWinds in the first place wasn't through SolarWinds, right? So there are certainly other initial access mechanisms that this group can and will be using.
Yeah, and that being said, I mean, there will be another SolarWinds. Of course, it won't be named SolarWinds in the future, but this has been proven quite successful, I think, for the threat actor who is behind it. So definitely, whether it's through SolarWinds or in the future via different software components, the methods definitely will be built upon.
Okay, next question. This was a very sophisticated attack. Could we analyze and presume what other mechanisms in the future will be utilized more?
Yeah, I think a couple of points on that. I think certainly all the techniques related, again, to Azure, Active Directory, ADFS, are all going to be highly relevant for a long period of time. I think you'll see a number of adversaries emulating those or trying to use those exact same techniques in victim environments. I also believe that we have to, as Bart mentioned, not only this group, but I mean, we've always known as a security community that supply chain risks, third-party risks were always present, but we didn't really do too much about that other than some compliance components in most organizations that I work with. So what I've been recommending to a lot of organizations, especially in a higher risk category, is to think about architectures that either isolate or put key third-party software into enclaves, tier 0 enclaves or protected enclaves that significantly limit their in and out traffic, that are closely monitored, that you don't automatically whitelist, which tends to be the case for, again, trusted software. The security community, security operations teams tend to just whitelist those services out and don't pay any attention to them. We really can't do that any longer. We now know that you have to look at that and model that traffic and model those behaviors and look for the unusual patterns in those environments. So I think there needs to be a little bit more of a consideration for architecture of third-party applications and software at the very least, and along with the hardening of your identity and access management architecture. I think those two things will be enduring regardless of this specific attack, and what that at this stage has been primarily mitigated in terms of the command and control and the access mechanisms, but there'll be another one, as Bart mentioned, no doubt about it.
Yeah, and I think specifically, the main takeaway is also the pivoting to the cloud, right? I mean, for many organizations, if you have an actor that moves to the cloud and uses these mechanisms, for many organizations, they lose visibility. And then they can be noticed for a number of weeks or months. So that's definitely also something that will be different, I think, in the future, is organizations will be paying attention to, or I hope will be paying attention to this mechanism, but we can also expect all the threat actors to make use of that.
Okay, another question. You said that you observed that the threat actor had also another campaign. Do you publish, or do you plan to publish reports about those incidents?
Yes, if and when we can. I mean, again, there's a lot of community activity in general now, and a lot of reporting coming out from a variety of both government agencies and private sector, analyzing not only this attack, but the broader, targeting and other potential linkages. So I think we fully intend at some point to release a full report, you know, sort of like when we do our APT-X reports when we can. We have enough there. As we continue to investigate, you know, our investigation's concluded, so we're not going to learn anything further from our own intrusion. We're still working in other victim environments and learning more. And of course, we're going to obviously put this into our data modeling and intelligence functions to see if we see other potential connection points, right, to other activities. So as we learn more, we will be publishing that in our intelligence reports, and we'll likely put more public reporting as well. It's just, again, it's hard to say when, right? This group is very, very good, and there might not be a lot of breadcrumbs and easy, you know, connection points there. So it may take a long time. So it's hard to say, you know, when and how we'll be reporting additional information, but we are certainly committed to doing that when we can.
Okay, great. I think those were all the questions. Unless someone else has another question, please ask. You mentioned that they were very stealthy, that the attack could last for years. So what were the key mistakes that the attackers made?
I think maybe
one
one
of the key mistakes.
Oh, sorry.
Go ahead, Bart.
Yeah, no. So one of the things I think that surprised a lot of people, certainly also within our own organization, was they're using this kind of supply chain attack, right? And then having spent a lot of time and effort on trojanizing a third party, and then using this to deploy within an environment, and then they drop something like Beacon, right, which is a very common red teaming tool. So that's definitely something that is a yes, they were quite stealthy within the environment itself, but also using some of the more commodity malware. On one hand, yes, indeed, using commodity malware, very common malware, not commodity malware, but common malware like Mimikatz or Beacon. On one hand, that kind of makes attribution a lot harder. On the other hand, we have also quite a lot of detection mechanisms around that. So maybe, I don't know if it's really a mistake or not, but at least that has been useful for us in detecting some of the activity.
Yeah, we like to joke that the mistake they made was attacking us. We actually, in all seriousness, we do know that through going back through some of our analysis after we learned about this capability, we were able to definitively say that we had, you know, us and others had investigated this group previously, and they just never made a connection to the supply chain component. So again, I think their technique paid off in that even if they were detected in some way, the remediation that happened in those environments was not complete, right? And we now know that they were able to get back in through this implant. So even in cases where they were investigated, you know, by fairly, I would say, advanced defenders, the dots were never fully connected. So their end goal of maintaining access and not having somebody uncover the full scope of what was going on was working, right? It was working for 9 months at least, March through March through December of 2020, until we finally put that last piece of the puzzle together with the supply chain component. So I think if that work hadn't been done and we hadn't put those number of man hours into all that analysis, really chasing a hunch, right? We might, again, we might have written this off, and others as well. We remediated as best we could. We don't really fully know how they got in, but we move on, right? That's what you do in a lot of cases. And they would have likely had access back into our environment, and of course continued on in the other environments they were in really undetected. So I do think from that perspective, you have to think about the full attack lifecycle, not just detection of one element, right? So just because you found one piece doesn't mean you found the whole puzzle, and it certainly doesn't mean that you've remediated everything. And that's the tricky part of any incident response, is getting to that confidence level that you fully understand what happened and it's been fixed.
Okay, great. And this is the last question. What this attack will be marketed and scaled to sell via the market? So could it be rolled out on a big scale campaign?
Potentially, but I don't believe, based on the evidence we have and what we think the attribution is likely to turn out to be, that's the modus operandi of this group. It's not something that they would normally sell or provide access to other groups to use. The other thing you have to think about is if you do go down that commodity path of selling that kind of access or providing it more broadly, it increases the chances you're going to get detected pretty dramatically, actually. So I don't think that's the case here. I don't think we'll see it. We certainly haven't seen it to date. Future operations, maybe, right? If a different attack group with different motivations were able to insert a supply chain backdoor somewhere else and subsequently sell that access to a wider array of groups to use, yeah, it's certainly possible. Nothing to stop that from happening.
Okay, I thought it was the last question, but this one is then the last question. Is a supply chain attack via Windows Cloud Services now a bigger possibility in the near future? Future.
Yeah, I think
we have no evidence.
Yeah, sorry, Ron, go ahead.
Yeah, we have no evidence that there's a cloud side of this equation. In other words, they certainly pivoted to cloud, but they weren't able to directly compromise cloud components, as far as we know and understand. Is that a possibility? It always is a possibility with technology, right? Things are moving very rapidly, new development, new capabilities. I wouldn't put it out of the realm of possibility, but in this case, the evidence is in the other direction. It started on-prem, it started through on-prem implants, and then moved to cloud. And I do think that's the majority of the attacks we see in cloud environments actually start somewhere else and then pivot into cloud environments.
Yeah.
Okay, great. That's it. Thank you very much, guys. It was very interesting, really. It's amazing work you guys did. Thank you, everyone, for joining us and staying. So that's very good. The attendance rate was very high. So that means you guys really know how to woo a crowd. So thank you very much. And until next time. Okay, goodbye. Thank you, everyone.
Appreciate it. Thank you.
Thanks for your attendance. Bye.